Okay, in this video, we're going to do 5.2. What are the chances is the chapter, but probability rules is the name of the section. And these are your objectives. So describe a probability model for a chance process. Use basic probability rules, including complement rule and the addition rule for mutually exclusive events. Use a two-way table of Venn diagram to model chance process and calculate probabilities. Use a general addition rule to calculate probability. So the Venn diagrams I'm going to do in another video, so hopefully I can get through the two-way table stuff first. Okay, probability models. So in section 5.1, we use simulation to imitate chance behavior. Fortunately, we don't have to always rely on simulations to determine the probability of a particular outcome. Descriptions of chance behavior contain two parts. So you either talking about a sample space. A chance process is a set of all possible outcomes, right? So everything that can possibly happen is your sample space. And then a probability model to describe some of the chance processes, and that probability model contains two parts: the entire sample space and then the probability of each outcome. Okay, so the set of all possible outcomes is a sample space. So, for example, if you're rolling a dice, like in a dice, the set of all probable outcomes are, 1, 2, 3, 4, 5, and 6, right? If you're talking about heads or tails or a coin, the entire sample space is just heads or tails. If you're talking about in a classroom, the names of all your kids would probably be your sample space. So it just depends on what it is you're talking about, but it's the set of all possible outcomes. Okay. And then when you're talking about probability for rolling two dice, things like that, we'll talk about that in a second. So here's an example of rolling two dice. So in one dice, you had the probability of getting a 1, 2, 3, 4, 5, and 6. But if you roll two dice, you have the probability of getting 1 and 1, 2 and 1, 3 and 1, and so on and so forth. And you actually end up with 36 possible outcomes. And every single one of these 36 is a sample, right? So you have 36 available. Okay, and since the dice are fair, each outcome is equally likely. So each outcome has a probability of 1 out of 36. So rolling, I don't know, like a 4 and a 4, right, has a 1 in 36 chance of occurring. Rolling a 3 and a 2 has a 1 in 36 chance of occurring because, okay, and this is the part they don't really explain. Well, there's 36 of them, that's true. So one pair, would be 1 out of 36. But what they don't actually visually show you in this picture, which I'm going to do in a second, is how you're actually getting the 1 out of 36 and how you can get it faster, which is technically by multiplying. So if you have, let's see, I'm going to work over here on the side. I'm going to do it like this, right? So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we're looking at the sum, right? So the sum of 1 and 1 is actually a 2. The sum of 1 and 2 is a 3. The sum of 3 and 4 is 1 and 3 is a 4. 5, 6, and 7, and so on and so forth. Eventually, you get to sum of 6 plus 6 is going to give you a 12, right? Because you have 6 plus 6. You get a 12, and you can fill this in how you want to. Okay. Oh, sorry. 1, 2, 3, 4, 5, 6, and 7. Okay, so these are the sums, which is what you get. We're rolling two dice. Now, the other way to look at this, okay, is using an actual. You still get 1, 2, 3, 4, 5, 6. But I'm going to put the possibilities. So you have the possibility of rolling a 1 just in one dice is 1 out of 6, and each one is equally likely. And so is on the other side, 1 out of 6, 1 out of 6, and so on and so forth. And technically, the way that you would get a 2 would be to multiply. 1/6 times 1/6 is just 1 out of 36. So each one has a 1 out of 36 chance, or each sum has a 1 out of 36 chance of occurring. And you keep on doing that for all of them. So you could either list them out, right? Or you can actually multiply and know for a fact that, hey, you know what? Each one of these are equally likely, so that just means 1/6 times 1/6. That's the fastest way. If each are equally likely, the fastest way to get 1 out of 36 is, well, 1/6 times 1/6. Okay. All right. Next one. So the probability model allows us to find the probability of any collection of outcomes. An event, okay, so an event is any collection of outcomes from some sample process. So an event is a subset of a sample space. So an event being the sum of 5, right? The sum of 5, the sum of 5, the sum of 5. That's what we're going for over here. Events are usually designed by capital letters like A, B, C, D, and so on. So, for example, if A is an event, we write the probability as P parentheses A. It's not P multiplied by A, it's just the probability of getting event A. So it would look like, using the quotation sum of 5, it would look like the probability of sum of 5. That's what it would look like. Okay. What are the 4 outcomes that result in a sum of 5? For example, since each outcome has a probability of 1 out of 6, the probability of getting a sum of 5 would be 4 out of 36. Because you have one pair, second pair, third pair, fourth pair that can actually give you a sum of 5. So it would be 4 out of 36. Okay, and then lastly is, suppose that event B is defined as the sum is not 5, right? So it could be, some could be 2, could be 3, could be 4, could be 6, 7, 8, 9, 10, 11, or 12, right? All of those put together, okay, is defined as probability of event B. What would that probability be? And the question, and so what you would do, the fastest way to do it is to take everything, right, 100%, subtract out what you know the sum of 5 actually is, which is 4 out of 36, and whatever you're left with is 32 out of 36. Or you can sit here and you can count, okay, well, this pair over here is not a 5, this pair over here is not a 5, this pair over here is not a 5, that's a 5, this pair over here is not a 5, this pair over here is not a 5. So your only 5s that actually occur are 1, 2, 3, 4. These are the only ones that occur that are 5s. Everything else is not a 5. So you could either sit here and count how many you have, or since you know you have 36 of them, you can take away 4 from 36, which gives you 32. That's another way to do it. So you decide which way is faster for you. If you want to sit here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth, there's only 4 of them that are 5s, the rest are not, so just take away 4 from 36, you get 32. Okay, so that was a basic probability. Hopefully it's a little bit of a refresher for you. But if not, you can pause and rewind that part. Okay, next are the basic rules of probability, and this would make more sense. There's a bunch of next two slides have a bunch of words on them. So I am going to use the pierced ears example from your book. Basically, it breaks it down by gender. I really don't like the fact that gender is up here. I don't know why. It just bugs the bejesus out of me. So I usually just gender. I don't know. It's just weird to me. Okay, so gender or pierced ears. Yes, no for pierced ears, gender male, female. You have a total of 178 kids or students, I think, that were surveyed, and there's your results. Now, in order to do the rules of probability, we're going to use the examples from in here to actually answer the question. Okay, so for example, first one, the probability of an event is a number between 0 and 1. Okay, that should make sense because any probability should be between 0 and 1. So you can get something like, 67%, or, 0.67, or you can get, I don't know, 67 out of 100, right? So any of those would be just fine as long as you interpret it correctly. Any of those are between 0 and 1. Okay, all possible outcomes together must have probabilities whose sum is exactly 1. So what it's basically saying is, if you add up, let's go back to the dice, for example. If you add up 1 out of 36 plus 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 1 out of 36, you do this 36 times, you should get 36 out of 36. So that will be all possible outcomes together, added together, so summed up, must have probabilities whose sum is exactly 1. So you end up getting, 36 out of 36. Or in the case of my peer steers and my students, if I add up 19 plus 71 plus 4 plus 84, this box right here, okay, if I add up these 4, then I should get 178. So we can say, 19 plus 71 plus 84 plus 4, that should equal 178. That's my out total. Okay, it's these guys in here. 1, 2, 3, 4. Not the total sides. The total 103 plus 75 should equal 178, and 90 and 88 should equal 178, which is fine. But this sample space, technically, are these 4 available spots right here. 1, 2, 3, 4. Okay, and then if all outcomes in the sample space are equally likely, if they are equally likely, that's a huge if, okay? The probability that event A occurs can be found using the formula, well, just like we did for the dice. The number of outcomes corresponding to event A being, a pair or whatever sum you're looking for out of the total number of outcomes, like 1 out of 36, right? If they are equally likely. And then the probability that an event does not occur is 1 minus the probability that event does occur, like the dice. So if you know 100% of your, if you know all of your dice, 100% was, 36 out of 36. This would probably be better to do this like this. 36 out of 36, right? And I subtracted 4 out of 36, then I should get 32 out of 36. Because there's 36 out of 36, which is the same as 1. Okay, so 1 minus the event that you don't want should give you the event that you do want. Okay, now, the next one. If 2 events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities, which sounds kind of weird, but I don't know how to describe this. Let's say you have a dice, right? So you have let's say you have a dice, and you have 1, 2, 3, 4, 5, 6 available, and then you also have, besides just a dice, you have spinner. A spinner being like a circle, and you have, a third, and a third. 1/3, 1/3, and 1/3, right? And let's say you have orange, I'm just making up colors. Pink and blue? Sure. Orange, pink, and blue. Okay. If one has nothing to do with the other, then you can just add up the probability. So, for example, what's the probability of getting a dice and getting a 3 on the dice and getting an orange, right? Getting a 3 on the dice and then getting an orange. So that would be like what? 1 out of 6, and then this would be 1 out of 3. So since they have nothing to do with each other, I'm just rolling a dice and then a spinner. I can just add those up. So 1/6 plus 1/3, and that would be it. So if I'm looking for a probability of, what's the probability of getting a 3, and then what's the probability of getting orange, it's just 1/6 plus 1/3. I'm just summing them up. But, okay, next thing. Two events A or B are mutually exclusive or disjoint, so they have nothing to do with each other, so they have no outcomes in common, so can never occur together. That is, probability of A and B equals 0. And I'm going to use the Pierce-Steers and the males in a second here. Okay. If they are mutually exclusive, so that means they have no outcomes in common, the probability of A and B should be equal to 0. And I'll show you what that looks like with the Pierce-Steers. Okay, so let's do probability of A and B. So let's say probability of male and Pierce-Steers. The question is that equal to 0? That's the part we want to know. The male and Pierce-Steers, so A and B, this is probability, this is event A occurring, this is event B occurring. Is that equal to 0? Well, the probability of male and pierced ears, if you look on our table, is man and yes would be 19 out of 178. 19 out of 178. Is that equal to 0? Well, obviously no. Okay, so that means they are not. So no means they are not mutually exclusive. Okay, so they do have outcomes in common. Because if they were mutually exclusive, they have no outcomes in common. But they are not mutually exclusive, so they do have outcomes in common. So they can occur together, which is the more important thing. They can occur together at the same time. Okay? Okay, now, the next one. The addition rule for mutually exclusive events. If you find out that two things cannot ever occur together, okay, then you can say, oh, okay, well, probability of this happening or that happening is basically adding these two up together. So probability of pierced ears plus probability of, of a man, and you can just add them together and you don't have to worry about it being the or part, which is this part right here, what I did up there. Okay, one or the other occurs. So if I know, for example, from the dice, okay, that the dice has nothing to do with the spinner, so if I do probability of the spinner and the dice, the outcome would be 0. I'm not going to do that right now, but you see my point. This has nothing to do with that. If I know that they have nothing to do with each other, then I can say, oh, okay, well, probability of dice or spinner, or orange spinner, or rolling a 3 on the dice, is the same thing as 1/6 plus 1/3. Sorry if you can't see. Probability of rolling dice on 3 on the dice or getting an orange spinner is just 1/6 plus 1/3. Okay, so add those probabilities together, and that's your probability of getting a 3 or getting an orange. Okay, next part. But here's the bottom part of the whole thing. If you don't know anything, how should I say, if you don't know that they're mutually exclusive or not, because sometimes it's kind of difficult to check, or you just forget to check in general. The best way to figure out if two things are mutually exclusive is to just use the general addition rule for mutually exclusive. For any two events resulting from some chance process. You're basically finding the or part. And I'm going to use this with the pierced ears. So what if I wanted to know, okay, the probability of being man male, or having pure steers. Okay. All right. Well, I didn't check exclusivity, so I don't know if they're exclusive or not. But I actually did over here. So that means they can occur together. So if you know they're not mutually exclusive, you have to use this rule. There's no other option. You can't use the top one because those are for only mutually exclusive events. But since we did find out that being male and having pure steers is not mutually exclusive, then we're going to use the general addition rule. So man or pure steers. So this is the probability of male plus the probability of pure steers minus the probability of male and pure steers. I would just say PE. Okay, so probability of male being, okay, go back to the paper. Okay, everyone who's a guy is 90 out of 178. So 90 out of 178 plus everyone who has pure steers, which is 103 people out of 178 people. I'm sorry, 103 out of 178. Subtract out everybody who's in the intersection of man and pure steers, which is 19 out of 178. Okay, and then you add those, subtract that, and that should give you the probability of the male or pure steers. Whatever this plus this is minus 19. Okay. All right, next one. Which is actually what we just did. Didn't I do this? Oh, we did the last one. We did C. Is a male or has pure steers. Okay. That was the last one we just did. So I didn't do has pure steers. So we have everyone who has pure steers is 103. Okay, so 103 out of 178 is a male with pure steers. Male with, oh, we did do these. 178. And we got whatever it was from the other one. In the previous problem. Okay, so that's it. Hopefully you followed along. Please watch this again if it didn't become clear what we were doing with them, especially the probability rule for the or. That's the one you really have to memorize, which is, I'm going to highlight it for you, this one, right over here. Please make sure that you get this one memorized. That's the important one. And then mutually exclusive, you have to check, is the probability of A and B equal to 0. If they are, they don't have any outcomes in common, so they can never occur together. Okay? It's equal to 0. If they're not equal to 0, that means they can occur together, which is what happened with the man and the pure steers over here. Okay, any questions? Please circle what is a little confusing, and then make sure you ask me in class to clarify. Thank you.